Okay, welcome everyone to lesson 6. This is our Godot Beginner Course, and well, now I'm not live in the server because I won't be able to be present at our discussed time, which is uh, Thursday 8 p.m. GMT +2. But yeah, I'm gonna make this recording, and now there's no one to miss the live session, I guess. And our YouTube has been actually blowing up. So, I mean, not like insane blowing up, but there's been an increase. So, I suggest everyone joins the Discord server who's watching this because we hold the lessons live, and we also have a chat going here where you can just, ask if you have any questions and all that. And yeah, we have a really great community assembling here. So today we are gonna be talking about something pretty important, and that's collisions mainly. We're actually almost halfway through the course, so pretty great progress and nice dedication for those of you who are still watching. So yeah, okay. Collisions and contact points is our title, and we have a bunch of different scenarios to go through. So I'm not gonna go in this order now because maybe starting off with this is better instead of the mouse. Or, I mean, doesn't really matter. Yeah, let's start with the mouse detection. It's pretty simple actually. So we have talked about control nodes, right? And things that are part of the UI. And these are capable of detecting when the mouse enters them. How? By signals. You can see it's under the control signals, the mouse entered and mouse exited, and we can use these to create pretty good mouse detection systems. For example, if you want to change the color of something when the mouse is in bounds, we can actually try that on this very label here. I will attach a script. We're gonna call it hover label. And then we just connect these signals to label 2. It's pretty important what we connect to. Like that. And then we'll need a variable to check if we are in bounds. Is mouse in bounds. This is going to be a boolean, which is false by default. And then when we enter, it is true, and when we leave, it's false again. And in the input, we'll need to look for the left click, right? Whenever we click with the mouse, so that we can actually detect a mouse click as well inside the boundaries of the label. So we can create this as an input action, or we have is mouse button pressed. However, this doesn't have a just pressed equivalent as it is right now. So just be aware of that if you're working on something like this. And we'll also need to see if the mouse is in bounds, right? And we can also set the modulation to be like gray or something where the mouse is in bounds, and otherwise when it exists it's just white. And we can take this one step further, saying So we print that, right? I'm gonna keep this simple for you. So modulet equals color dot, let's do brown or something like that, I don't know. If it's being pressed, and otherwise we do the color of hovering. It's not working. We are on level 1, right? So let's try to find out why. And it is this. So I think we've talked about the mouse filter before, but basically if this is set to ignore, it won't be able to detect mouse interactions. Now if we set to stop, you can see the breakpoint triggers immediately. And if I click it, it changes color. And so this works. What if I put this label above it, right? See, now we can barely like get into the boundaries. And that's because you can see the actual size of this other label, right? And these, since it is above the hover label in the node hierarchy, this basically eats the mouse capture. If I put it like this, now we can access it again completely. Okay. That's basically mouse detection. And then I think you can also detect the mouse on something like this. Yeah. Okay. Yeah, we'll get into that just now. So when you want something to have a collision, you can use a lot of collision types. So the root object is collision object 2D, and then there are physics bodies and the area 2D. And the difference is that area 2D basically just detects colliding. It doesn't have boundaries. You cannot bump into an area 2D. And the name is pretty self-explanatory, right? Because it's just an area, it's not a body. However, if I create a body like character body 2D, now this is saying a warning. This node has no shape, so it can't collide or interact with objects. So in Godot, to create the actual collision boundaries of something, we can either use collision shapes or collision polygons. And then collision shape, you have the shape property that you need to set to any of these shapes. There are just a lot to pick from. I'm gonna go with a rectangle for now. And then you can change its size here. If you just modify that, you can see it's centered around the collision shape node. And you can use collision polygon, which basically lets you like draw the shape for yourself. It's pretty good for more complex shapes and collisions. Okay. So actually let's wait. Yeah, let's put the collision on this guy. Or like the other way around, right? It's usually a good convention to put the collision as the root of something, for example a character, and just the sprite beneath or the looks, you know. Okay. Are we... wait. Oh yeah, this gets reset, okay. I'm just gonna remove this. This is from our previous activities. Okay, there we go. There is a Godot guy. I'm gonna comment the generation out. Those kind of downscale this, like that. Okay, and now if I want to create a script, oh wait, I didn't know this. Okay, wait, pay attention. So, if I attach a script, the character with a 2D. Wait, is it? Oh yeah, because it's already created. Wait, this is really cool. Hang on. So basically, there's already a boilerplate code for this type. If you attach it to the script, see, basic movement. And this is pretty good. Okay, so now we are falling down. There's a lot to go through here, so hang on. Let me create a platform. So for platforms and like things like that, we typically use static bodies because, as the name suggests, they are not going to really move. And we can make this like 2000 or something. And now it just stays there. And now we can move and also jump. So that's what the code template gave us. We will go through this in a second. Oh yeah, if you ever bump into issues with collisions and want to debug it, here's this debug tab, and you have visible collision shapes. So now if I run this, you will see all the collision shapes in game as well. So yeah, that is a nice feature. Okay, so luckily I don't have to write all of this. So let's see what we do here. So, you know, there's gravity, of course. These are just some constants defined for the jump speed and the default movement speed for walking left or right. And gravity, this is a constant also from the project settings, because in the project settings, and this is the settings path, physics to the default gravity, yeah. You can retrieve this for a unified gravity unit among every node, because you can configure that, and every collision by default will behave as such, and that it will take gravity into consideration from the project settings. Okay. So we are in physics process, right? This is typically used for physics calculations to run at a fixed frame rate. So the first thing we see here is if not is on floor, and you may be able to guess this, but basically this checks if you're grounded or not. So now I am grounded. Now I'm not, you know, while I'm jumping. And so we only apply gravity when we are not on the floor. This is a check for being able to jump. So UI accept is bound to jump here, which is either space or enter. You can actually modify this if you show the built-in actions You can see it's here. And of course, you should only be able to jump if you are on the floor. This is a built-in method for collision objects, by the way, and it is really useful. Or, oh wait, is it only an character body? Seems like it. Okay, anyways. So there's that. And then, yeah, we had the jump velocity. We could make this a bit faster, right? And this is a negative because in Godot, the higher you place something, the lower the Y position is. Okay. Alright, so if I adjust this no matter what, we're not gonna get quicker, right? Jump velocity basically is just the distance from the ground that we reach. So just modifying the gravity would spice it up rather. So if I do that, see now this is also super fast, and like we make less amount of distance because the gravity is stronger, and like, you know, that's just kind of obvious. And then this, I think we've done something like this before, but this is just the horizontal motion. And then move and slide. You can read this, but basically this moves the body so that it takes other things it collides with into consideration. And this is why we don't just do position.x plus equals whatever, you know. You may also notice the use of this velocity variable, which is like not defined here, so it's actually built in, right? It's a built-in also to character body. And then move and slide does the calculations based on this velocity. And then you can detect the mouse here with character body as well, just like you could on controls. And I think rigid body is the last physics body type we haven't covered. And now this has a lot more signals. You can detect other bodies with this, right? And rigid body is much more complex. It just has a lot of things. So yeah, this is much more this is much closer to real life physics, I would say. I can actually wait, if I attach a script, does this? Oh yeah, this doesn't have a basic movement stuff. Such a shame. Okay. Just copy and paste these. And you can see I actually added no code to rigid body, but it still fell down. And yeah, see, they are just colliding with each other. This is a bit misleading, so I can just create a circle shape and make it be like, oh wait, what is it, like 45 units, 47, there we go. Now I can do the same thing on this. Okay, that's a bit more accurate. And you can see the character body moved as well. And actually I can just jump and make this move further. Wait, hang on. Yeah. I cannot push it, however. And I don't like fall off its top. I think, yeah, those are useful as well. Because, so, yeah, this is turned off by default, also the contact monitor. So these are needed for signals. Because if these are turned off for the max contacts reported is like insufficient, then the signal emissions won't happen, and that may just cause issues, you know. And then there are just a lot of settings. You can read through the documentation to like get a grasp of all of these, because there's just a lot really, and like a lot of great tutorials out there as well that like go deeper into these, but you know, we can't quite do that in these shorter sessions. Okay. So one pretty interesting thing we have is raycasts. Raycast is basically what it sounds like. So there's a point and you emit a ray in a direction. We also have notes for that. Raycast 2D. And you can see it as 2 points, right? Basically that's the target position. You can set what it collides with. And collision mask is also really important. So if I set the collision mask of the character body and the layer to nothing, basically it will fall off the surface of the map. So here's layer and mask, and you can see the note for explanation. So object A can detect a contact with object B only if object B is any of the layers that A scans. And the mask is basically the opposite of this in a way. So now if I make this things for both layers, the first and second, and this is in the second one, the two objects won't collide, but they will both stay on the platform. See? Pretty cool. And then we have Raycast. And yeah, this is a bunch of things. You can see you can retrieve the thing it's colliding with, but the first thing it's colliding with at a time. I can actually just print it here. So if Raycast to the get collider equal null, right? Because otherwise it would crash. Then we print its name. Yeah. So now it's pointing at the platform, right? Now I changed the arrow's direction, it's pointing at the rigid body. So this object. And raycasting is often used for like navigation also. And if you just wanna quickly see if there's something ahead of you, technically. But in navigation, it's often like if the if the node is looking facing this direction, right, then there will be like 5 raycasts or something placed evenly. And then based on what the raycasts return, it can adjust its direction, right? So if there's a wall here, these 2 raycasts will give that away, and the character will change direction to the left. And yeah, there's just a bunch you can do with character body. Like, it does a lot of great built-in functions. There's also its own wall. These are also determined by raycasting, by the way. At least that's what I'm thinking, and it is oftentimes the case. Also in Unity, where I don't know if there's a built-in right now for Unity that that has a similar function to is on floor, but back in the day we had to do raycasting to detect if we are on the floor. So yeah, and then we can set that motion mode. Oh wait, I cannot. Wait, oh, I can't move. Yeah, this depends the behavior of move and slide. I thought we'd be able to like just move as we wish if we are in floating. Well, slide doesn't really mention this. Oh well. Yeah. Yeah, it is for top-down games, so oh wait, because maybe we should not apply gravity, and then like yeah. I mean, it should still persist if we give this ungrounded, I think. Yeah. Yeah, well, anyways, there's just a lot to do. It's like really I can't explain all of it because there's just no time. And then we have area 2D, which again requires a collision shape. And this is typically used for like detecting proximity and allowing interactions to like open a chest or something. Because you can see it has a variety of signals you can use for both other areas and then bodies. Area shape and body shape essentially are for these nodes, if I'm not mistaken. This is so that if you want to get specifically what shape you collide with, so if a character like hits you in a third-person game, right, and you want to know whether they attack you with their right or left hand, you want to use these area or body shapes, because the area enter and body enter only return the actual node body. So in this case, it would be rigid body and not collision shape, if that makes sense. And I think that is it essentially for collisions. So I hope you enjoyed, and make sure to subscribe and enter our beloved Discord server. Thanks so much, and goodbye.